points A, B, C and D have coordinates -4, -3, -1, -6, 3, 2 and -2, 1 respectively. Find the vectors AD and BC and explain the meaning of what you have found about the line segments AD and BC. Now the first thing you should really do is, it's very useful to plot the points onto a graph. Now I did this using this GeoGebra applet, okay, and this GeoGebra applet will be included in the notes of this YouTube video. So what we will do, we plot the points. You can plot the points onto the graph. So we've got A is -4, -3, B is -1, -6, C is 3, 2, and D is -2, 1. Okay, so what we're going to do is we're going to calculate the vector A to D. Now if I click this over here, okay, we'll get a bit more information. This is the actual answer, but let's see how we can get to the answer. Now go from A to D, I need to go from A to the origin, and from the origin to D. Now the thing is, once you plotted a point onto a graph, the vector from the origin to the point is now called a position vector. So the two orange vectors here are position vectors. Okay, so in order to find the vector A to D, I need to follow a route. So I need to follow the route A to O plus O to D. But notice on the vector A to O, I'm going against the arrow of the position vector, because the position vector gives me relative from the origin. And this is a very, very important concept to realise, okay? So, going back to this, here's a screenshot of what I've just done. Okay, so note, OA and OD are what we call position vectors, and AD is not, it's just a vector in space. So AD, so going from A to D, like I just said, it's the same as going from A to O plus O to D. It's very, very important to get that concept realised. That's very, very important. So therefore AD, we are going against the arrow of the position vector. So we need to put a minus sign and then write the coordinates as a column vector, -4, -3. The minus sign means we're going in the opposite direction, so we're going against the arrow of the vector. This one, for the second one, we're going with the arrow of the vector, so we just write plus the coordinates is a column vector, -2, 1. It's better to use column vectors. Right, simplifying this vector, we take this vector, this becomes 4 plus 4 plus 3. So I've written them red on purpose, plus -2, 1, and then we just add the corresponding components together. 4 plus -2 gives 2, and 3 plus 1 gives 4. Okay, and we can see very easily from the diagram, for every 2 squares we go along, we go 4 up. Okay, for the other vector, which is we need to find is BC, this one here. Go back to the GeoGebra applet, just unclick this one and click this one. Again, we've got position vectors OB and OC, because they tell us the position relative to the origin. And to find the vector BC, we've got a similar sort of thing. We're going OB, so we're going against the, BO, we're going against the arrow of OB, but we're going with the arrow of OC. Alright, so we're going to have that BC is minus OB plus OC. And again, I've got this GeoGebra applet in the notes of the video. So BC is going BO, so against the arrow of that one, plus OC. So there's going to be minus the coordinates written -1, -1, -6 written as a column vector. Minus in front because we're going against the arrow. And this one we're going with the arrow, so we can just write down plus 3, 2. And then minus 1 and minus 6 gives me 1, 6. Plus 3, 2. Add together the corresponding components, we're going to get 4 8. That's the answer for BC. Now, we might have noticed that 4, 8 is twice 2, 4. What we're saying is vector BC is twice vector AD. Now, what does that actually mean geometrically? Well, we can see very clearly that this line here is parallel to this line here. Also, this one is twice the length of this one. If you think about it, this one we go 4 along and 8 up, so it's 2 lots of 2 along and 4 up, 2 lots of it. Okay, and this one we just go 2 along and 4 up. So this tells me now 2 things about the line segment BC. It means that BC is parallel. So if you can show that 2 vectors are equal, or one is a multiple of the other, then the two line segments will always be parallel. But because this is now 2, this is now twice the length of the line segment AD. And therefore, in general, for 2 vectors u and v to be parallel, if u is equal to some number, scalar number, this is sort of a number, constant, times v, then the 2 vectors are parallel. And if the number's like 2, then one's twice the length of the other. If number's 3, one's 3 times the length of the other. If one is 1.5, then one is 1.5 times the length of the other. This is what it tells us. Okay, so this has been a video to show you about position vectors and how to find vectors on a coordinate system between 2 known points, and to show whether vectors are parallel or not, or how times longer one length is than the other. Okay, I hope you've understood, and I thank you very much for watching. Again, I remind you the GeoGebra app is in the notes of the video.